Hello everyone, I'm going to help you study some limits. First, let's go over the first way most people learn to evaluate limits with a table. You have x minus 3 over x squared minus 9. And your limit is x to 3. When you look at this first, you'll see that x here, if you put in 3 for x, you just get 0. That's not what we want. What we want is to get a limit or something close to the answer. So, draw a table. You want to make it look something like this. With 7 spots. Put in the very middle 3, or this number right here. No, not that one, my bad. I meant put in this number, whatever x is equal. And then put the number, the number minus 1, then 0.999. Then the number minus 1, 0.99. And then number minus 1.9. And then take the number itself, write it, and then 0.001. 3.01 and 3.1. This is the progression of it getting bigger and smaller. So you would first write the equation and then put 2.9 in for x. What you would get is 0.169. The next two will be 1.67, no, 0.167, and then the final one will be 0.166. This is what really matters. If you want to skip the rest of them, you can, but I don't recommend it. So 3.001, plug it in, get 1.666. And at this point, you can see 1. Yeah. But what's the difference between this? What? Well, you would find whatever is between these two, whatever number you can see between these two, and put it in. I may have gotten this wrong, but I believe the answer is 1. Do not quote me on that. Next, we're going to be evaluating limits when you can just plug the item in. So let's say you have x plus 2 over x squared plus 2x minus 3, and your limit is x2. Now, you can just plug this in. You get 4 on top, and the bottom, 2 times 2 squared is 4. 2 times 2 is 4. You get 8, and you minus 3 from 8, and you get 5. And the 5 is under it, so you get 4 over 5. There's your answer. Now, let's get to my least favorite way. You have something like this. Square root over the square root of x squared plus 5. And you need to plug this in to some coordinates. 3. You need to plug it in. Not some coordinates. Let's say you just need to plug this in. You need to find whatever it can equal. So, let's do that. First, you take the equation x plus h parentheses minus x over h. Now you would plug this in and get our buddy over here, x squared minus. No. Almost forgot, but you would get this. From that equation, you would get the square root. X, or parentheses x plus h and parentheses squared minus or plus 5 being subtracted by square root x plus 5, x squared plus 5, all over h. Now you would multiply this out. Well, not multiply it out, but you would, on the side, you would multiply it by the conjugate. For this one, it's square root, parentheses, x plus h, parentheses, and parentheses squared, plus 5, plus the square root of x squared plus 5. You would conjugate that through and get our goal. We'll get this guy. A lot of things would cross out, but you would get x plus h squared, still in parentheses, don't forget that, plus 5 minus x squared plus 5. Now you would basically have to multiply this negative to both of them and get negative x squared plus or minus 5, which would cross out both 5s. You would multiply this guy out to x squared plus 2xh plus h squared, which would subtract this guy, and you'd be left with 2xh plus h squared over h. You could take h out from all of this, get 2x plus h, and these h's would cross out. Or you would take an h out, the h's would cross out, and you'd be left with 2x plus h in your answer. Now, don't forget, the limit for most of these that are certain of this that you have to plug coordinates in, let's say our coordinate would be negative 2, 12, the limit will always be x is 0. You plug in 0 for h would be removed. Now it's just doubling the x. So, for this one down here, this x is negative 2. It would just turn the negative 2 into negative 4. 12. Next, find the limit using limit algebraically. Alright. Take your problem at the square root of x plus 2 minus square root 2 over x, and your limit is 0. Well, x to 0. If you plug that in, it's not going to work because x is just going to be 0, so let's try a different method. Take the conjugate of the top one and multiply both of them by it. The square root of x plus 2 plus the square root of 2 on both of them. You'll end up with you multiply it out is you multiply this one by it and this one by it, and you get x plus 2 minus 2 over x square root of x plus 2 plus square root of 2. These guys cross out. Yay! And these x's would also cross out, leaving you with this over 1, which is just square root of x plus 2 plus the square root of 2 all over 1. And then you could have one thing left. You plug in the 0 for x, removing the x entirely, and now just having square root of 2 plus 2, which in simple terms becomes 2 square root 2 over under 1. This would be your answer for the following equation up here. That's how you would solve with anything that has a square root in it. You want to use conjugates. Should have gone over that earlier. Now, here's an easy one. If it's a perfect square. No, you have a perfect square, which is 25 minus x squared. It's a perfect square. You could just, and since it's a negative, very important, you would turn one of them into a negative. So it becomes x minus 5 over x minus 5, parentheses, x plus 5, parentheses. And then you would cross it out and have it come out to 1 over x plus 5. Not to forget, our limit in this equation would be 5. So 5 plus 5 is 1 over 10, being our answer. The next one is a little bit more tricky. Alright, so you want to find the slope form of an equation. Let's take a simple one. 4 minus x squared. Now you want to plug this in the equation. F of x plus h, parentheses around them, minus f of x in parentheses over h. Now, let's get going. There's two ways to solve this equation right here. A simple way and a much harder way that you will be asked to do to get full points. I've checked. So, you can plug this in over here. Plug it in. And now this equation up here turns to 4 minus, parentheses, h plus x, or x plus h, parentheses n, squared, minus 4 minus h squared. So, first you want to FOIL this guy out, and don't forget it's all over h. FOIL this out, and by the end of the foiling, you will end up with an equation looking similar to this. 4 minus x squared, important to note, oh, hold on, I have forgotten. You must multiply this out before you finish, making this a negative 4 and this a positive x. Very important. Do not forget that step. I should make it perfectly clear here. This means you are multiplying everything inside to negative form, to the opposite form. Let's continue down here. 4 minus x squared minus 2xh minus h squared minus 4 plus x squared. Now, let's see what can cross out. Both our 4's can cross out, and both our x's can cross out. Anything without an h is immediately crossed out, and this equation turns from all this simply negative 2xh minus h squared over h. And this would shatter into negative 2x minus h, and the h's would be remove 1h from this. So this would be removed, this would cut down by 1, and this would be removed entirely, turning it into this equation. And then you would plug in your limit. For most of these, that are similar to this. If to define derivative, you would turn the h into a 0. So this is being subtracted by a 0, making it come to negative 2x. You plug your x in, and there you go. Now, a much more simple equation is this. But you have to do this one to get full credit. You must do the long way. Here's a short way to check your answer. Remove any number that does not have an x. Change any number that has a single x into 1. Any number that is larger than a single x will turn into this. This will turn into negative 2x. Now, any other equation. Let's say x to the power of 3. Nothing else is around it. You bring the 3 down, 3x. And from here, you would have e squared by 2. For simpleness, xd will turn into d times x to d minus 1. This is what your end equation will always look like. If it has no x, it becomes nothing. And finally, last, and certainly not least, is the limit of infinity, or to infinity. Take an equation like this, for example. 3 over x squared since it's an x on the bottom, the x will always be put to infinity as your limit, which should be simple. You can get that out of the way. That becomes 3 over infinity, and anytime it's a number like that, it becomes 0. Now, here's an easier way to look at it. Take an equation like 3 over x squared. An equation like 3 plus x, and then 3 minus x. And finally, an equation like x2 over x plus 3. These all represent the 3 forms it could possibly be. If there's no x on top, it becomes instantly 0. Any equation similar to this one, and there has 2 x's that are equal to, if it has an x that is too large, such as this one, which is x being squared, then it's automatically infinity. If these x's are equal, then you have to do some math. This one, you would divide everything by x. Now these x's would be... No. These would be disqualified into zeros. Anything that does not have an x would instantly be disqualified into a 0. And you always take whatever you're dividing everything by x by, the largest x in the denominator. Not the numerator, the denominator. So this equation will come out to be, since both 3's cross out, into 0. And 0, and so these x's both cross out into 1, you will have 1 over negative 1. And that's your answer, which entirely translates into negative 1. So, that's the easiest and simplest way to look at that. Thank you for watching.